Hello everyone, welcome to another video in the sort of bridging program for the MetE17 for the omitted lessons in our MetE17 class last sem now. So today in this video we'll be talking about Pourbaix diagram. So Pourbaix diagrams are typically diagrams that show you the stability of aqueous electrochemical systems. Okay, and they are usually known as your EH-PH diagram because in the y-axis you have your EH, or the electrochemical potential. The H in EH stands for hydrogen now, because when we're taking electrochemical potentials, we usually measure it against a standard hydrogen electrode. Okay, then on the y-axis, on the x-axis, we have your pH, which is a measure of the acidity, no? Where pH is equal to the negative of the logarithm of the H plus concentration. Okay, so in most diagrams, in the Pourbaix diagram, you will see something that looks like this, where you have different phases, and at different EH and pH combinations you can have stable phases now. So for example, in this region we have Fe3 plus is stable, this one Fe2 plus, here it's FeOH3, and so on and so forth. We'll also notice that we have sort of broken lines here, no? And the broken lines here signify your what we call as your stability lines, no? These stability lines are the stability lines for water. So in constructing a Pourbaix diagram, we follow these steps now, and this is much the same steps as we took when we did the pressure diagram now. So yung una is to determine the number of equilibrium expressions that need to be considered for the given number of species. So again, we identify the number of species na gusto natin, and from there we derive the number of expressions, or the number of couples that we need in order to produce our diagram. So we use the same formula, which is n times n minus 1 over 2. And for example, if we have 4 species, then that will be equal to 4 times 3 over 2, which gives us 6. Okay, so we write the chemical reactions as reduction reactions using H2O, H plus, and E minus to balance the expressions. Okay, so this is important, though. We need to write this, or we need to write our chemical reactions as reduction reactions now, and later we'll see why this matters now. Then number 3, we determine the standard reduction potential for the different reactions, and we can do this in 2 ways. Either we get it from standard tables, or we get it from the Gibbs free energy values using an equation. So if we use the standard tables, you will see something that looks like this, and this table is the standard electrode potential, no? And this V naught here is the same as E naught, no? Sometimes it's known as E naught or V naught. And again, these electrode reactions are measured against the standard hydrogen electrode, no? Where your standard hydrogen electrode has a value of 0, no? So the other method is to use this formula, no? Where it relates your Gibbs free energy, your standard Gibbs free energy, with the electrochemical potential, no? Or sometimes known as your cell potential, no? The cell potential is just equal to the negative of the delta G naught divided by N, where N here is the number of electrons in the chemical reaction, and F in the balanced chemical reaction, that is, and F here is your Faraday's constant. Okay. Then step 4 is we write down the Nernst equation for the following system, and the Nernst equation is given as E is equal to E naught minus 0.0591 over N times log of K. Okay, E here is your EH. So the 0.0591 here comes from the simplification of negative RT over F. R being the gas constant, T being the temperature, and F being the Faraday's constant. So we are assuming that we are at 298 Kelvin here. Okay, so in itself, we can't yet plot the EH pH from this the EH versus pH diagram or equation from this given equation. No, so we need to express K first in terms of the products and reactants, and usually one of the products or one of the reactants will be H plus, and if we take the concentration of H plus, then if we take the logarithm of the concentration of H plus, and that is the negative logarithm of H plus, no, that is the pH. So one of the terms here will simplify into pH, and this term here will be your EH, and therefore this is the Y value, and the other term will be the X value, no, the pH. Tapos yung iba will just become constants or will become coefficients or slopes, no. So later I'll show you more how it will look like, no. Then after you get the different equations, then much the same way as we did with the pressure diagram, we just plot the different equations in terms of EH and pH. Okay, and we use the same rules na ginamit natin, no, wherein we look for areas of coincidence, or where each stable regions coincides with the other lines, no, with each of the different lines that are involved. Again, we determine the stability regions with the following general pointers observed. An equilibrium line transforms from stable to unstable and vice versa whenever it crosses a triple point. And ito na-discuss naman natin from the previous lecture. Tapos, around the triple point, an alternation of stable and unstable line is encountered. Okay, and the oxidized species are observed above, while the reduced species is observed below. Okay, and this is a consequence of the Le Chatelier's principle. So let's try this example now. We are to draw the EH-pH diagram of Fe3 plus, Fe3O4, and Fe2O3. So that's 3 species in water, and we are given an ionic concentration of 1 times 10 to the negative 6. And this is in terms of molarity, no? Because usually, if you remember, the activity of a dilute solution is just given by its molar concentration. Okay, so this is important because usually this is important because in drawing Pourbaix diagrams, this is usually given, no? So kung ano yung magiging concentrations ng yung ionic components that are not H plus, no? Okay, so later papakita ko sa inyo kung saan natin sinasubstitute tong ionic concentration na to, no? So in this case, if you look at the different species involved, no, there is only one ionic species, which is the Fe3 plus. Kaya ito lang yung binigay na ionic concentration. So in some diagrams where you add or where you analyze multiple ionic species, then you can define concentrations of the different species. And if you change the concentration of the different ionic species, nagbabago rin yung itsura ng Pourbaix diagram natin. Okay, so let's identify the number of expressions or number of couples that we need to generate. We have 3 species, therefore the number of expressions is just equal to 3 times 3 minus 1, which is 2 divided by 2. That gives us 3 expressions now. So if we did the different couples for this, first we have your Fe3 plus and your Fe3O4. So the way we balance it is to use H2O, E minus, and H plus. So I'll show you how we can generate this now. So let's just let me transfer to my whiteboard now. Okay, so we'll try Fe3 plus, and we are forming Fe 3O4. Okay, so Fe3O4. Okay, so we have oxygen on this side, so let's add oxygen, H2O, and there is 4 oxygen here, no? So let's multiply this by 4. Now let's balance the Fe. We have 3 Fe here, so we multiply it by 3 Fe. Then since there are 4 times 2, 8 hydrogen atoms, so we'll balance it with 8 H plus here. Okay. Now that we've balanced the the elements, we need to balance the charges as well now, since this is an electrochemical reaction. No? So we have 3. So we have 3 times 3, that's 9 plus charge here. And here we only have 8 hydrogen H plus species, no? So this becomes 8 plus charge. So para ma-balance out natin, then we add 1 electron here. So that becomes 9 plus negative 1 gives us positive 8, and that is now equal to positive 8 sa right side din. Okay, so that's why if we look at it, we should get this balance equation. So that's 3Fe3 plus 4H2O plus E minus yields Fe3O4. So let's try another one now, and I'll leave the third one for you guys to practice on. Okay, so we have Fe3 plus to Fe2O3. So let's try it. We have Fe3 plus to Fe2O3. And again, we always write it as a, I don't know, as a reduction reaction. So we know that the charge of your Fe here is, and let me go back to this case now. So if you look at it, the charge of Fe3 plus here is 3 plus, while the charge of your Fe here is, actually that's 4 times negative 2 divided by 3. It's actually positive 8 thirds. No? So you'll notice that from 3 plus, na-reduce siya into positive 8 thirds because 3 is just 9 thirds. No? So this positive 9 thirds is reduced by 1/3 charge. No? Okay, so we can also look at it in this second couple or expression. No? So we have Fe3 plus, and the charge here is, this is 3 times negative 2. So yung oxygen natin has a charge of negative 2. No? And you probably know that by now, no? Since nag-chemistry naman kayo. So that's negative 2 times 3 is 6 divided by 2. Divided by 2 gives us 3 pa rin, no? So 3. So actually you can, it has the same charge, no? And because it has the same charge, we will probably expect na wala tayong electrons involved dito, no? Kasi kumbaga walang reduction involved sa reaction na to. So we can write it either way, no? Pwedeng forward reaction like this, o pwedeng reverse reaction, no? So let's balance it out. And this is meron tayong H2O, again H2O on this side, and since tatlo yung H2O natin, so tatlo yung oxygen, so we had 3 H2O. Then you have 2 Fe iron, so multiply this by 2. Then para ma-balance out, lagay tayo ng how many? 6 H plus, no? Okay, and let's look at the charges. So notice 2 times 3, that's 6 plus yung charge dito, or positive 6, which is equal to yung dito 6 plus 6 siya, no? So again, walang change, no? Because and it becomes fairly obvious, no? Kasi if you look at it, yung again, yung minention ko kanina, yung 3 plus natin, from Fe3 plus dito, hindi siya nagbago yung charge na dito. So again, you can also write the reverse reaction, no? That will be also equally correct. And later, papakita ko sa inyo paano natin i-evaluate, no? Okay, so that's your writing or balancing your equations, no? And yung last one, I think you can do this on your own again, no? So again, just remember alin yung nare-reduce. So yung nare-reduce dapat, or yung higher charge dapat you write it on the left side, tapos yung reduced charge is on the right side. So in this case, from Fe, eto 3 plus yung charge ni Fe here, and dito again yung charge niya is yung 8 thirds, no, or tama, yung 8 thirds. So therefore dito yung reduced charge. Then you balance it out again using your H2Os and your H pluses. Okay? Okay. So next, we are given this, I don't know, yung delta G ng different species. Then from the delta G, we can now compute for the the E naught values, no, for uh, the different reactions, and we will use those E naught values to solve for the Nernst equation, no? Okay, so the first one, let's evaluate the this is the first reaction natin, no? So that's Fe3 plus reducing into Fe3O4, and let's try to compute for the delta G. So this is products minus reactants. 8H plus here has a delta G of formation equal to 0 because this is the stable form of hydrogen in aqueous solution. So kaya siya negative, kaya siya 0 siya. So 0, and Fe3O4 has a delta G of formation equal to negative 242.4. So ito siya, negative 2.4. Si Fe3 plus has a delta G formation of negative 2.52. Si H2O has a negative delta G formation of negative 56.69. Okay, so if we did the math, we should get delta G of reaction is just equal to negative 242.4 minus 3 times negative 2.52 because there are 3 moles of Fe. And we have 4 times negative 56.69, which is, this is your H2O, no? Because there are 4 moles of H2O. And it should give you 8.08 kilocals. So now that we have your delta G, which is equal to, again, negative 8.08 kilocal, we need to convert this into your electrochemical potential or your cell potential, no? So the way we do that is to use the formula given earlier, no? And I can show you here. So we have your E naught is equal to negative of delta G naught over N, which N here is the number of electrons involved, multiplied by Faraday's constant. So in our problem, we have delta G is equal to negative 8.08 kilocal, and the equivalent Faraday's constant for for F is 23.06. That is volt per kilocal. No, sorry, that's kilocal per volt, I should say. Okay, and we multiply it by volt. This is per kilocal per volt equivalent, no? And we have one electron, therefore this is one equivalent, no? And we have a negative sign here preceding the entire term. So negative negative, this becomes positive, and if you did the calculation, we should get this value. Okay, so that's equal to positive 3.504 volts. Okay, so the next one is your equation number 2, wherein you have Fe3 plus yielding Fe2O3, no? And we've noted earlier na walang reduction in volt dito, no? Kasi walang change in charge, and wala tayong electron na involved, no? So in that case, hindi natin pwedeng gamitin si Nernst equation, no? So the way we do this is, instead of using Nernst equation, gagamitin natin yung delta G is equal to RT ln KQ. Okay? So in that way, pwede natin makuha yung log pH as a constant value, no? Or pwede natin makuha yung logarithm of the concentration of H plus as a constant value, and therefore makakuha tayo ng pH equals a constant. Okay, so that's important because pH equals a constant is also a line equation of a line, no? And this line, if we plot it in your EHPH, is actually just a vertical line, no? Okay, so your log KEQ is equal to negative of delta G over RT. Okay, so so this is your negative delta G. So again, we get the negative delta G just by using Hess law, no? We do products minus reactants, so that's Fe₂O3 is negative 177.1, and again, itong si H plus, wala siyang yung free energy niya is equal to 0 kasi H is stable or H plus is the stable form in aqueous solution. Okay, so minus 2 times Fe3 plus, which is negative 2.52, tapos 3 times H2O, which is negative 56.69, and this should give us negative 1.99 kilocal. Okay, so ang gagawin natin dito, instead of computing for E0, i-relate natin siya sa log K. And again, kaya natin ginawa yun kasi walang electrons involved dito, no? So hindi natin magagamit yung ano tawag dito, yung Nernst equation, no? Kasi if you notice, yung sa Nernst equation and even in this equation, no, meron tayong n term doon sa baba, and if our n is equal to 0, which is the case here, then we have an undefined na value, no? So hindi natin magagamit again si Nernst equation. Okay, so ginamit natin yung equilibrium equation, which is delta G is equal to negative RT ln KQ. Okay, so if we rearrange that, we get log KEQ is equal to negative of the delta G divided by RT. Okay, so kaya may 2.303 dito. This is because we converted ln KEQ into logarithm, because if you remember, ln K is just equal to 2.303 times log K. Okay, so if we did this, we do negative of negative 1.99 times 10 to the 3 because it is kilocal, and yung gas constant natin for in terms of calories is 1.986 calories per mole Kelvin multiplied by 298, which is the temperature of our system, no? Then divide it again by 2.303, which is yung conversion factor from ln to logarithm. Then we get this value, no? So log K is equal to 1.46. Okay, so standby muna tong two equations na to. Mamaya ano natin, no, i-input natin yung K natin as a in terms of the reactants and the products, no, para maipalabas natin yung pH value. Okay, so dito this is the third equation. Fe₂O3 yields Fe3O4. Okay, so this is the reduction reaction, and we take the delta G of reaction, again products over reactant lang. So this is a products minus reactants, I should say. So that's 2 times Fe3O4 plus yung sa water, and this is just 1 mole, so 1 times negative 56.69 minus 3 times Fe₂O3, which is negative 177.1. Tapos again 0 si H plus, because it is the stable form of hydrogen in water. Okay, so this should give us negative 10.19 kilocals, and we again use the equation E naught is equal to negative delta G over NF to find the number of volts, no? And in this case, yung N natin is equal to 2 because there are 2 electrons involved. That's why 2 yung factor dito si N. And 23.06 is yung Faraday's constant, no? In terms of calories. So that's 23.06 kilocalories per volt per equivalent. Okay, and the number of equivalent charge is 2 in this case. Okay, so we should get 0.2209. Okay, so if we were to do the Nernst equation, for the first equation, this should give us E, and again the Nernst equation is EH is equal to E naught minus 0.0592 times logarithm of K. Okay, so the first equation, if we go back to the previous slide, is E naught is 0.3504 now, so that's why it's E is equal to E naught, which is 0.3504 minus 0.0592 multiplied by the logarithm of K. Okay, next is we have equation number 3, which is this one. This is equal to E equals 0.2209 minus 0.0296 logarithm of K. Again, 2209 here comes from E naught, which is this equation here. Okay, so it's 0.0296 kasi this is 0.0592 divided by N, no? And again, N here is 2 because there are 2 electrons involved, so, or 2 equivalent charges involved. So that's why 0.04592 divided by 2 gives us 0.0296 times the logarithm of K. Okay? So, notice na hindi na natin ginawa ng Nernst equation yung equation number 2, no? Because again, wala siyang electrons involved. So, kung gagamitan man natin siya, then yung over N dito, mangyayari lang is maging undefined yung term na yun, no? So, it will not be possible. Okay, so from here, from the Nernst equation and from the equation 2, itong equilibrium constant equation, we can now have expressions relating EH and pH, no, by expanding this K term, no. So we will expand also the K term here, and we will also expand the K term here and here. Okay, so let's try the equation number 1 first. So again, it's E is equal to 0.3504, this term, minus 0.0592 divided by N, which is 1, times the logarithm of K. So if we expand K, this is equal to the activity of Fe₃O4, which is the product, no? This product activity of H plus raised to the power of 8 because there are 8 moles in the reaction. Tapos we have activity of Fe3 plus raised to the power of 3 because there are 3 moles of the Fe3 plus, and lastly we have A of H2O raised to the power of 4 because there are 4 moles in the reaction, no? And we also multiply it by the activity of the electron, no? Okay, so these 3 terms, itong Fe₃O4 and these 2 terms first, Fe₃O4 and an activity of H2O is just equal to 1 because these are stable condensed phases, no? So or pure condensed phases. Pag again from MetE17, you remember na pagka condensed yung phase, wala tayong charge or yung activity niya is just equal to 1. Tapos yung activity ng electron is just equal to 1 as well, no? Okay, so this will simplify to the activity of H plus raised to the power of 8 divided by the activity of F3 plus raised to the power of 3. Okay, now if you remember your chemistry, whenever you are taking the activities of dilute na solutions, no? The dilute solution or species in dilute solutions, then the activity of that species is just equal to its molarity. Okay, so eto the molarity of Fe3 plus is given, no? And pero the molarity of H plus is not given. Then we have, if we simplify this, if we break this logarithm down, this becomes 8 times log of the molarity of H plus, no? So we can just express it as the molarity of H plus minus 3 times the logarithm of Fe3 plus. Okay, now if we distribute 0.0592 times 8 gives us 0.4736, and that's negative, pero since pH to, kaya nawala yung negative. Sige, I'll probably show this, no, sa parang whiteboard ko para mas makita nyo, no. So sige, let's just copy this. So lipat tayo sa whiteboard. May pwede sigurong i-burahin ko to. And copy natin na, no. So we have 0.3504. Okay. So that's 0.3504 minus 0.0592 times 8 log, and again H plus to, no, parang we can express it, the activity can be expressed again as just the, I don't know, molar concentrations. Okay, plus 6 log, I'm sorry, this is supposed to be minus 3 log pala, I'm sorry, 3 log ng Fe3 plus. Okay, so if we distribute 0.0592, we should get 0.3504 minus, that's minus 0.4736 multiplied by log H plus. Okay, but we remember that log H plus, that pH is equal to negative log H plus, no? Okay, or negative pH is equal to log H plus. So if we substitute negative pH here, then we should have, this becomes plus 0.4736 pH. Okay, itong term na to, we can just express it as 0.4736 of the pH value. Okay, then ito, this is again 3 log Fe3 plus. Okay, so again, this is EH is equal to EH. Yan. So meron tayong Y value na to. This is our Y, this is our X, and we have this term, no? But remember sa problem natin, again, pagka nagpo-Pourbaix diagram tayo, usually sineset natin kung ano yung ionic concentrations, no? And in this case, given naman kung ano yung ionic concentration ni Fe3 plus, which is doon sa problem, if babalikan natin yung problem, no? We have yung Fe3 plus is just 1 times 10 to the negative 6, no? Okay, so if we substitute it, and sorry, balik tayo, no? So we have plus 0.4736, and by the kaya siya negative pala kasi negative yung i-multiply natin. So negative times negative, kaya positive to. Okay, so that's positive 0.1776, so that's negative 0.0592 times negative 3, 0.016 of logarithm of the Fe3 plus concentration. Then if we substitute this Fe3 plus concentration, ang matitira sa atin is EH is equal to 0.4736 pH minus 0.7152. Okay, so etong 0.7152 comes from 3504 plus 0.1776 multiplied by logarithm of 1 times 10 to the negative 6. Okay, so we should end up with this value, no? And this now is an equation of a line, no? Kasi itong EH is the Y, pH is the X, and itong value na to is your Y-intercept or the B. Tapos ito yung M, which is the slope, no? So Y equals mx plus B. Okay, so we have the first equation. Ito na ang first equation natin. Now, let's proceed with the second equation. So, again, as a second equation, if you remember, wala siya kasing electron involved. So, hindi Nernst equation siya, no? So, gagamitin natin is yung equilibrium equation. Wherein, sabi natin, KEQ is equal to yung negative, or yung log KEQ is equal to negative, and I'll probably show it dito. So, ito yung kinumpute natin, no? Yung log K is EQ is equal to negative delta G over 2.303 times RT. Okay? So, we've determined log K is equal to 1.46. Now, i-expand na lang natin itong K na to. So, 1.46 here, 1.46 is equal to logarithm of the products over the reactants, and yung products natin is Fe₂O3 times the activity of H plus raised to the power of 6 divided by the activity of Fe3 plus raised to the power of 2 multiplied by the activity of H2O raised to the power of 3. Again, the Fe2O3 and H2O are pure condensed phases, therefore activities nila is just equal to 1. No? So this cancels out, giving us logarithm of yung a to the 6th activity of H plus raised to the power of 6, tapos activity of Fe3 plus raised to the power of 2. Okay, so if you simplify this, we do the same steps na ginawa natin, no? So this becomes a logarithm of, and I can probably show you, no, para mas malinaw. Okay, so that's 1.46 is equal to log ng activity of 6H plus divided by activity of Fe3 plus raised to the power of 2. Okay? So again, ito equivalent lang sa logarithm of H plus, molar concentration of H plus, because these are dilute solutions, no? Tapos ito, Fe3 plus raised to the power of 6 to raised to the power of 2. Tapos if we break the logarithm down, we should get 1.46 is equal to logarithm of 6 times logarithm of H plus minus 2 times logarithm of Fe3 plus. Okay? And we remember that your log H plus is equal to negative pH. Therefore, ito, papalitan lang natin. Magiging negative 6 pH. Oh, extend natin. Okay. Okay. So, this becomes negative 6 pH minus 2 log Fe3 plus is equal to 1.46. Tapos, tandaan natin na itong Fe3 plus is equal to 1 times 10 to the negative 6, no? Okay? So, pwede natin i-input yan dito. Tapos, magsisimplify ito into pH is equal to some constant, no? And that constant is equal to 1.757. Okay? So, this is equivalent to saying na x is equal to a constant, no? And when you have an x equals constant na type of equation, that is a vertical line, no? Okay? Now, we proceed with the last equation, which is similar to the first equation na ginawa natin, no? So, we have E is equal to E naught, and this is taken from yung delta G over NF. Delta G over NF, okay? So, ito, 0.2209 minus 0.0296, and again, ito siya. Pakita ko lang ulit. Ito siya nanggaling, no? Yung 0.0296. Yung 0.0296 again, kaya siya 0.0296 because the Nernst equation is 0.0592 divided by N. And N here is 2, no? 2 electrons tayo. So, therefore, So that's 0.0296 logarithm of yung activity ng water multiplied by the activity of Fe3O4 raised to the power of 2 divided by activity of Fe2O3 raised to the power of 3, and then the activity of your H plus multiplied by raised to the power of 2, then activity of your electron. Again, itong H2O, Fe3O4, and Fe2O3 are pure condensed phases, therefore 1 lang sila lahat. And your electron is also just equal to 1, no? Yung activity. Therefore, you are left with log ng 1 over a activity of H plus squared. Okay? Then again, ito is just your it's just your H plus, no? So if I write that down, or that is your molarity of H plus. So if I don't know, let me just delete that ito. Clean tayo. Tapos, let me write that down again, no? So that's EH is equal to 0.2209. Sorry, 0.2209 minus 0.0296 multiplied by the logarithm of 1 over yung H plus concentration. Okay, so if we simplify this becomes 296, and this is a log of H plus to the negative 1, therefore ito ay negative log ng H plus. Okay, and negative log ng H plus is equal to pH, therefore 0.0296, and raised to the power of 2 pa pala ito, no? Raised to the power of 2, then therefore negative 2 log. Okay, para mas malinaw, negative 2 log. Ano siya? So that's 0.0296 multiplied by negative 2 pH gives me 0.0592. Okay, 592 times pH, and ito yung E-naught natin, 2209. So EH is equals to ganyan. So again, ito, this is Y equals MX plus B. So, okay, so that's an equation of a line. Okay, so we have 3 equations and we have 3 lines, and if we plot it, we should get something that looks like this, no? Let's try to plot it in Excel para mas makita natin siya in action, no? So let me open up my Excel. Okay, so let's transfer to Excel and let's try to plot the 3 equations now. Okay, so let me just shift to Excel now. Here, so I've already just pasted the equation, no, para may reference tayo, and these are the 3 equations na solve natin kanina. Okay, so we have the first equation, and again, like I did nung previous na na session natin, yung sa secret session, I placed 3 formulas, and let's call this as your yung first formula is the Fe3 plus to Fe3O4, no? Yun yung first formula natin, Fe3 plus tapos Fe3O4. Next is yung Fe3 plus tapos Fe2O3, tapos yung last equation natin is Fe3 plus Fe2O3 to Fe3O4. Yun yung 3 expressions natin, no? Or couples natin. Okay, I'll probably move this to the right para may space ako for the XY na coordinates, no? Okay, so we have X, we have Y. Ito X, Y, also X and Y, no? Okay, so just ko lang konti ito na. Oh, pangit pala. Gawin ko lang equal sila. Okay. So, the first equation, Fe, and this is Fe3 plus Fe3O4 is given by this first equation. No? So, that's equals, ang EH daw natin is 0.4736 multiplied by the pH, which is dito. Okay. Tapos i-drag down na natin. And actually, we only just need 2 points pala, no? Yung last time ang ginawa ko is I did 4 points. But unnecessary na yung 2 other points, no? Because you only need 2 points to create the line. So, pwedeng i-adjust na lang natin yung parang X values natin para ma-trim down yung line. Kumbaga, kung saan natin siya gustong i-trim, no? Okay? So, let's just do 2 points. The one start point and one end point. Okay? So, ito, since the pH values runs from 1 to 14, then pwedeng 1 to 14 yung gagawin muna natin, no? Tapos ito, 1 to 14 din. Okay. Sorry. pH values runs from 0 to 14. Okay. So, pwede 0 to 14 lang yung gagawin ko. Next is yung Fe3 plus to Fe2O3. And this is just a straight line, no, where x is equal to x is a constant. Okay, so actually ito magiging 1.757 and regardless of whatever y value we get here, x will always be 1.757. So later establish na tayo ng y value that will be inside our graph, no? Okay, so depending kung ano yung lalabas dito na y values. Okay? So, ito 0 to 14 ulit tayo. Sorry, 0 to 14. Tapos y natin is equal to 0. Negative 0.0592 multiplied by your x value plus 0.2210. Okay. And I think 2.09 yung nasa ano, no, naka-round off ata to. 09. And if I remember correctly, ZEV 7152 ata yun. So baka nag-round off kasi siya. Hindi ko pa pala nalagay ito. Minus 0. Sorry. This should be minus 0.152. No? And just to be sure, balikan natin, no? Yung PowerPoint natin. Okay, pag binalikan natin yung PowerPoint natin. Tama. 0.736 pH minus 7152 plus 2209 minus 0.0592. Okay? So, transition tayo. Balik tayo dun sa Excel. Okay. Ito, nag-round off lang siya dito, no? Ginawa yung 2210. Tapos dito, baka dahil sa rounding off, magkaiba yung dulong digit. Pero, maliit na bagay lang naman yun. Okay? So, 736. Let's see if it's correct. Okay. Mukhang tama naman. Tapos, yung range ng y values natin is from, I would say, this is negative 0.6 up to 6. So, just to be safe, I could do negative 1 and 6 probably. Ganyan, no? Para sakop siya, encompass niya itong dalawang to. Okay? So, if I insert, again, ang gagawin natin is punta tayo sa top ribbon, insert, tapos pili tayo ng itong scatter with straight lines, no? Ito, scatter with straight lines. Tapos dito sa scatter with straight lines, select data tayo. Tapos let's add an entry. And yung first entry natin is ito. And let's just select this as our name of the series. Our x value is this one. Okay. Our y value is this one. Okay? First natin. Tapos add pa tayo ng isa pang series. This series is equal to this value. X value is this one. Y value is this one. Okay? That's okay. And last is dagdag tayo nung last series natin, no? Which is this this couple. Okay? So X values dito. And again, Y values is ito. Okay? Now, ganyan siya. And to make it easier, let's add a chart element, no? And let's place data label, legends. And let's place it to the right para mas makita natin, no? Okay? So we don't need this equation anymore. Tatabunan ko na lang siya. Ganyan. And if we look at it, medyo malayo na tong 14 pala, no? If you look at it, we are interested dito sa itong maliit na region lang na to. And that's around negative 1 to 1. Parang sakop na natin lahat. So we can change ito, no? Ang gawin na lang natin is let's do negative 1 to 1 for the y. So that's negative 1 to 1. Tapos ito, adjust natin. Pwedeng from 0 to 4 lang, no? Parang enough na yun. So 0 to 4. Okay? Yan. Medyo zoomed in na siya, no? Okay na. Sakop na natin. Okay? Okay. So we have our different couples, no? And we have the legends to show this. And again, ang sabi, if we go back to the slides, no? If you remember, we always place the oxidized species above and the reduced species below. Okay? So that means that for our example, ito, and let me just insert, insert tayo ng text box na lang. So we do insert text box, lagay tayo ng text box dito para, So yung taas dito is the oxidized species, which is this one, Fe3+. Tapos yung reduced species natin is, and what I can do is, pwede sigurong ganito yung gawin ko, no? Fe3+, tapos Fe3O4 yung reduced species ko. Okay? So, pwede siyang ganyan, no? And, gusto ko lang. So, pwede ganyan. Okay? And let me just check kung tama yung ginawa natin, no? Tama naman. Okay? If you want to be more accurate, pwede namang ano ko to. Hindi pala pwede. Hindi pwede mag-exponent or mag-superscript pag naka-text box siya. So, okay na yan. That's good enough for us, no? Now, let's do, ano yung next natin? Copy lang natin yung text box, no? And do the orange line. The orange line is yung reduced species. And since ito is, ito ay a vertical line siya, then therefore, pwede tayong gumamit ng Le Chatelier's principle, no, para mas makita natin siya. So, if we do, let's do the, okay, let's look at this equation now. This is for the second equation. So, let's try to do Le Chatelier's principle now. Increase or decreasing the pH value is equivalent to increasing the H plus value, no? Tama? Because it's the negative logarithm of the molar concentration of H plus, meaning that whenever H plus increases, your solution becomes more acidic, and a more acidic solution is translated as a lower number, no? So closer to 0 means that you are very acidic. Closer to 14 is that you are very basic. Okay? And 7 is the neutral. If you remember your chemistry, no? So ibig sabihin dito, if i-increase natin yung H plus natin, increasing H plus here means that you are moving to the left of the x-axis, no? Kasi binabawasan mo yung pH mo. So, increasing H plus or moving to the left causes stress on the right-hand side. Therefore, ang mas favored is the reactants, no? Which in this case is Fe3 plus. Okay? So, if that's the case, then Fe3 plus should be the one on the left, tapos Fe2O3 should be the one on the right. Okay? So, ulitin ko lang, no? H plus here, in-increase natin siya, and that translates to a lesser value for the pH, no? Or a lower value for the pH. So, that is equivalent to moving to the left of the x-axis. Okay? So, if move tayo to the left of the x-axis, ang stable phase natin is Fe3 plus because by Le Chatelier's principle, to alleviate the stress of increasing H plus, we are favoring the reverse reaction, favoring the reactants, no? Okay? So, we transition back to the Excel file. Then, dapat ito, this is Fe3 plus to the left. Tapos to the right is Fe2O3. Fe2O3. Okay? And yung last natin is yung Fe2O3 and Fe3O4, which is this gray line, no? And parang naalala natin na yung gray line, yung taas na value or above the line will be your oxidized species. And in this case, ang oxidized natin is Fe2O3, tapos yung reduced species is itong Fe3O4. Okay? Okay? So, ito na yung regions natin, no? Different regions. Tapos, ang gagawin na lang natin is to identify yung parang coincidence ng mga regions na ito, no? Kung saan sila nagko-coincide, kumbaga. Okay? So, Fe3 plus is upwards or to the left of this line and upwards of this line. So, kung saan sila nag-meet, it's actually this area, no? Ito and ito. Anything to the left of this region and upwards and left of this line will give me Fe3O plus. Therefore, this is a triple point. So, if this now becomes solid and this is now this is also solid. Therefore, ito magiging metastable siya, which is a hidden line na siya, no? So, hanggang dito lang dapat yung yung point ko. So, that is around, 1.75. 1.757 actually siya, no? Kasi x equals 1.757 dito. So, dito, this is 1.757. Therefore, isa-stop natin yung Fe, itong orange line natin hanggang dito muna. So, that's around 0.2. So, I can do 0.2. Oops, sorry, balik that. So, that's 1 to 0.2 dapat dito. And 0.2 is an overestimation. Na dapat 1.5 siguro probably. No, 1.6. And again, pwedeng i-ano nyo to class, no? The way you can do this is pwede nyong ipa-intersect na lang tong line na to with any of these other lines pa kung gusto nyo makakuha ng exact solution, no? Pero ako, I think the best way for me, the quickest way is estimate ko na lang, no? Sorry. Dapat pala pabaliktad. 13. Somewhere around 12, no? Yeah. 0.12, we will meet yan, no? So again, kasi di ba pag nag-intersect yung line, that is saying na that is the solution of the system equations for both of those lines. So, pwede actually yun yung gawin nyo, no? But, medyo tinatamad na ko siyang gawin. So, ang ginawa ko na lang, nag-estimate na lang ako. Tapos, nag-input ako ng values para maputol ko yung line na yun exactly at this point. Ito, si Fe3 plus Fe3O4, dapat titigil siya dito, which is, we know is 1.757. Tama? So, that's from 0 to 1.757 siya. Okay, so I'll input dito 1.757. So, hanggang dyan lang yung line ko. Tapos, lastly, ito, Fe3O4 is stable papunta sa baba, and let me just write that line again, no? So Fe₃O4 is pababa siya dito. So parang ganyan siya, no? Pababa dito sa gray line, and pababa and to the right of this blue line. So yung intersection nila is etong area na to, from here to here. Tama? So dito dapat stable siya, tapos ito yung metastable niya. So if I did that again, yung ginawa ko dito is 0 point, sorry. Ito ginawa nating 1.757 para maputol yung blue line hanggang dito. Tapos dito naman, ang gagawin natin sa sa gray line is from here to here lang siya. Tama? So, we'll change the 0 to 1.757. Okay? Now, ito, ilipat lang natin siya dito. Ito, ilipat na natin dito. And, pwede natin gawin tong one text box na lang. So, ito is the Fe₃O4 region. So, I'll say Fe₃O4 to. I'll probably make this larger, no? Ayan. So, if this is Fe₃O4, this is Fe₂O3. Tama? So, ito siyang intersection. And you can delete this now, no? Tapos, ito dito sa left side is Fe3+. So, I can do Fe3+, such. Okay, so this is now my stability, or my Pourbaix diagram for the species Fe3+, Fe₂O3, and Fe₃O4, given that the ionic concentration of your Fe3+ is at 1 times 10 to the negative 6, no? Which is given in the problem. Okay, ito 1 times 10 to the negative 6. Sorry, balik tayo dito. Tama, ito yung problem kasi. So, these are the 3 species na pinapanap sa atin. Tapos, ito yung ionic concentration. And, it's given na it's already given na 298 yung natin, no? Yung temperature natin. Okay? Okay. So, kung hindi 298, pwede naman, no? You can have Pourbaix diagrams that are not in 298. Pero, kung hindi 298 siya, hindi natin magagamit directly yung itong 0.0591. Kasi ito is naka-simplify from RT over F, no? Where T is set to 298. Kaya siya 0.0591. Pero kung gusto nyo elevated temperatures, then dapat compute nyo mismo from RT over NF. Similarly, ito din, yung ito, okay lang pala to. So, ito, dito siya magbabago, no, doon sa Nernst equation. Pero kung naka 298 lang, then you can use this simplified na equation where E is equal to E0 minus 0.0591 over N times log K. Okay, so one thing that you need to do for Pourbaix diagram, kasi notice na si Pourbaix diagram is this is done in aqueous solutions, and therefore hindi nagme-make sense kung mag-go beyond tayo sa stability ng water. Tama? So, it is important na ilagay natin yung stability ng water natin. And if you do the stability lines, water stability lines, which is yung H plus yields H2, pati yung H plus plus O2 plus 4E minus yields H2O. Then you should get 2 lines, no? One line is E is equal to negative 0.0591 pH, and one line is E is equal to 1.229 minus 0.0591 pH. Tapos pag dinrawing nyo yung line na to, you should get something that looks like this, no? So what this line means is that anything above this line, hindi na stable si water, so hindi na aqueous actually itong portion na to. So, hindi na nagme-make sense na magpo-Pourbaix diagram tayo dyan. Tapos, similarly, dito sa baba, hindi na rin stable si water, no? Only this, the boundary in between these two stability lines is where you have a stable or where water exists as a stable phase, and therefore you have an aqueous solution, no? Kasi stable pa yung solvent mo, kumbaga. Okay? So, hindi na nagme-make sense dito sa baba na kumbaga non-stable na si water. So importante na i-drawing yung stability lines, you know. And hindi ko na ipapakita, or siguro pwede ko ipakita kung paano yung water stability lines, no? Let's get back to Excel. Tapos, let's do another one dito, no? Sige, pwede ko naman ilagay na lang dito. So, water. Let's do yung H2. Tapos yung H2O. XY and XY. Tapos, yung yung first na stability line natin is E is just equal to 0.0591 pH. Okay? So, if we did that, E is Y is equal to this value times 0.0591 or 592. 0.0. Okay? Tapos, yung sa H2O naman, it's 1.229 minus 0.0591. Okay? Or 0.592. Sige, pwede namang 1. So, some textbooks have it 0.0591 and some textbooks have it 0.0592, no? So, it's based on parang baka nag-round off somewhere, no? Kaya magkaiba yung But you can solve it on your own, no? Try nyo na lang i-substitute yung RT over F kung ano yung closer value. So, I'll use 0.0591. So, again, ito is equal to 1.229 minus 0.0591 times yung X. Yan. Tapos, since ang X natin spans from 0 to 4, based dito sa diagram na to, pinili natin. So, ang gawin natin is 0 to 4. And 0 to 4. Tapos, pwedeng dagdag natin yung water stability line. So, select data. Let's add a water stability line. And let's take this as H2. X value is this one. And Y value is this one. Okay. Tapos, yung next is edit. No, sorry. Add another value. This one. This. And your Y value is this value. Okay. So, may something wrong sa okay. I know now. Kasi ang ginawa ko is 0.0591 times pero negative to, no? Kasi if you look at it, dito sa water stability lines, negative yung slope dapat. Negative 0.0591. Nakalimutan ko lang yung negative sign. Okay, so balik tayo. So this becomes negative. Let's just drag it down. Yeah. So makes much more sense. So this is the water stability line. And pwede pa lang we can go higher than 1, no? Para lang to show na mag-intersect yung water stability line. So we could probably do 1.5, no? Ganyan. Okay. So that is my and to be clearer, pwede rin gawin ko to. I can do format data series. Tapos gawin natin na yung effect nito is naka-dash line para consistent tayo dun sa mga common na representation of your water stability lines, which is dashed. Okay, so pwedeng ganyan siya, no? Okay, so we have completed our Pourbaix diagram. So this is the Pourbaix diagram. Okay. Lagay ko na para yeah. Okay, so that's the Pourbaix diagram of 3 species, Fe3+, Fe2O3, Fe3O4 at ionic concentration of 1 times 10 to the negative 6. Tapos yung temperature is at 298 Kelvin or 25 degrees Celsius. Tapos I've also shown the water stability lines now. Okay? Now, You can do this on your own, no? Try to practice, but let's just say you add one more species, no? Kunwari, si Fe2 plus gusto natin idagdag dun sa Pourbaix diagram natin. You'll notice that if you add one more species, ang mangyayari is magiging 4 species na sa lahat. So 4 times 4 minus 1, which is 3. So 4 times 3 over 2 gives you 6 equations. So pag 6 equations, you'll probably see something that looks like this, no? Which makes it a lot more complicated. Tapos, ang gagawin nyo is, kailangan nyo nang i-assess kung, again, mag-assess kayo kung saan sila nagko-coincide yung mga different regions, no? And which makes the most sense. Okay? Tapos, employ nyo yung technique na whenever you have a triple point, something like this, kailangan alternating yung visibility ng lines, kumbaga. So, whenever it passes to a triple point, mag-invisible yung line. Tapos, ano pa bang interesting dito, no? So, yun, medyo matrabaho siya, no? Pagka mas maraming, the more species are involved, then the greater number of expressions are needed. And because there are many expressions, this translates to many lines. And because there are many lines, mas mahirap mag-assess yung regions, no? Na kung saan nagko-coincide sila. Okay? So I hope through this video, you've learned more about how to create Pourbaix diagrams, no? So again, fairly similar siya sa yung diniscuss ko last time, which is the pressure diagrams, pero ang difference lang is we're dealing with EH and pH. And because we're dealing with EH, pH, kinailangan natin yung Nernst equation, no? Okay? So I think I can end this video here. And thank you for listening, and I hope you learned a lot today. I see you.